Hey guys, so welcome to the very first video of Mathematical Thursdays. In this video, we are going to be talking about this beautiful chapter, the first chapter of EM4, that is linear algebra. So here in this video, we are going to be talking about finding eigenvalues and eigenvectors of a matrix having unique eigenvalues. So let's get started. Okay, so we are starting with the very first question in matrices, that is find the eigenvectors and eigenvalues. So the first few things that is very important for us to know is what is characteristic matrix, characteristic polynomial and characteristic equation. When we talk about characteristic matrix, that will be given by A minus lambda I. Characteristic polynomial will be A minus lambda I in mods, and characteristic equation will be A minus lambda I equal to 0. Starting off with the first question, the question is A equals 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4 and 3. So to start with defining the characteristic matrix. So the characteristic matrix is defined as A minus lambda I, right? So that is going to be equal to 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, 2 minus 4 and 3 minus lambda. This is the characteristic matrix. Moving on, we go ahead and we find out the characteristic polynomial. So the characteristic polynomial is A minus lambda I, and it is also represented as lambda cube minus trace of A into lambda square plus SMD into lambda minus determinant of A equals 0. So we need to find trace of A. Trace will be equal to sum of all the diagonal elements, 8 plus 7 plus 3, which is 18. SMD is going to be equal to, so we take measures of the minus of the diagonal elements, so we hide these, and then the answer that we get is 7 minus 4 minus 4 3 plus this is the diagonal element now, so this is going to be, we hide these, it's going to be 8 to 2 3, and then for the last diagonal element it is going to be, we hide this, it's going to be 8 minus 6 minus 6 7. So now we go ahead and we calculate the values, which will be equal to 7 3s are 21 minus minus plus plus minus minus 16 plus 8 3s are 24 minus 4 plus 7 8s are 56 minus minus plus plus minus minus 36. So the answer for this will be 21 minus 16 is 5 plus 20 plus 20, which is going to give us 45. Next we find determinant of A, which will be equal to, okay, let me just clear this, 8 7 minus 4 minus 4 3, then we have minus, it will be minus of minus 6, and then the thing here will be minus 6 minus 4 2 3 minus 6 minus 4 2 3 plus 2 into minus 6 7 2 minus 4. So when we calculate it, we get 8 21 minus minus plus plus minus minus 16 plus of 6 into minus 18 plus minus 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 plus 8 plus 2 into 24 minus 14. This is plus 20, this is going to be minus 60, and this is going to be 21 minus 16 is 5, 8s are 40. So this is going to give us 0. Okay, so therefore we write that the characteristic equation is mod of A minus lambda I equals 0. So we write it as lambda cube minus trace was 18 lambda square plus SMD is 45 equals 0. So now we have to use our calculator to get the value. So we have to go in mode and equation and press option number 4, and I substitute the values. The answer comes out to be 0, 3 and 15. Now we have to find the eigenvalues. So I will find the eigenvalue first for lambda equals 0. So we will go ahead and define the characteristic matrix. The characteristic matrix is going to be given as A minus lambda I into x equals 0. So here, because our lambda is 0, so whatever is our given matrix is going to be used here. So I'll just copy the entire matrix. Let me just change the color as well. Okay, and this gets multiplied by x, which can be represented as x1, x2 and x3, and it is equal to 0. So 0, 0 and 0. Here all of these rows are unique, so we can use Cramer's rule. So by Cramer's rule, I have decided to use the second and the third row. So that would be minus 6, 7, minus 4, 2, minus 4 and 3. So using Cramer's rule, x1 equals minus x2 equals x3. Let's suppose it is equal to some value t. So here we will be having 7 minus 4 minus 4 3, and for x2 it will be minus 6 minus 4 2 3, and for x3 it will be minus 6 7 2 and minus 4. We go ahead and solve it. So it would be x1 upon 21 minus plus minus 16 equals minus x2 upon minus 18 plus minus plus 8, x3 upon minus 6 minus 4 24 minus 14 equals t. So when we solve all of these, we get x1 upon 5 equals minus x2 upon minus 10 equals x3 upon 10 equals t. So x1 gets represented as x1, x2 and x3, which will be equal to 5t minus 10 plus 10t and 10t. So taking 5t common, we get 1, 2 and 2. Okay, so I don't know what happened, but I was somehow not recording my audio. Anyway, so we have done the same thing for for lambda equals 3 and for lambda equals 15 as well. We have followed the same rule. We've used Cramer's rule. Here I have used the first and the third row because they were looking quite easy to solve, and for lambda equals 15 I have used the second and the third row for easy calculation. On the screen you can see I will be fast forwarding the clip so that you can see how the calculation really went, but this is a very easy method to get the values, because here none of the roots or none of the eigenvalues are getting repeated, so there is no problem. And here I am also checking if what I have solved is correct or not, and it is. So yes, that is it from my side, guys. This was finding eigenvalues and eigenvectors where the eigenvalues are unique. Thank you. So I also ended up solving another example where we get unique eigenvectors. So here this is the question: a equals 2 0 minus 1 0 2 0 minus 1 0 2. So here I went ahead and I have defined the characteristic matrix, and then I have defined the characteristic polynomial, and then we found the value of the trace, the SMD and the determinant of the given matrix. Then I have defined the characteristic equation and substituted all of the values. So we got the eigenvalues as 1, 2 and 3. Then I proceeded with finding the eigenvectors for the first one, which is lambda equals 1, and I have used Cramer's rule as we have done previously as well, and then got the value of x1 here as 101. Then for lambda equals 2, again we have used Cramer's rule and I got the value as x2 equals 010. For lambda equals 3, again I have used Cramer's rule and I got the value of x3 as -10 and -1. So here are all of the 3 eigenvectors and the values were 1, 2 and 3.
So I hope you like the video. I will see you again next Thursday to continue this lecture where we are going to be talking about finding eigenvalues and eigenvectors of a matrix where the eigenvalues are going to be the same. Bye.